All right, I'm going to talk about some radicals and rational exponents. I'm going to get through basically some real basic knowledge about them in this video, and then I'll expand a little bit more in the future. So first off, what in the world am I talking about when I'm talking about a radical or rational exponent? So you might hear me talk about radicals or root form, same thing. Basically, here's what it is. So when dealing with exponents, say we have the base of 7, and I take 7 squared, which everyone knows is 49. If I want to do the inverse of this, the inverse of taking something to an exponent is finding the root or going to the radical of it. So the opposite of taking 7 squared is 49. To go backwards or take the inverse, we would take, instead of the square, we're going to take 49 and take the square root. So this is also known as a radical, the symbol, but also a root. So take the square root of 49 and we get 7, so back at 7. And this is pretty traditional of what most students understand up to this point, but we're going to take it a little bit further. So if I took 3 and took it to the 5th power, that is 243. So if I want to take the inverse of that and go back to 3, I'm going to take the 5th root of 243 and get back to 3. So that's what we're talking about today, radicals or roots, whatever you want to do there, and rational exponents. So what we're going to do on this video is we're going to convert from one to the other. We're going to convert between exponents and we're going to convert to radicals. Radicals to exponents, and then I'll do exponents to radicals. And the reason I want to do that is just show the connection between, exponent form and root or radical form. So we're going to flip between the two. In general, what they're going to follow is our most basic ones. We're going to have a raised to the 1 over n power. So that's a fraction 1 over n. And when you do that, the denominator of the n, that is going to be what root we're doing. So the nth root of a. So a to the 1/nth power is the nth root of a. Notice the n in the bottom is the n that's attached to the root. Our base a just stays a. So this is going to be our most simple ones that we're going to see. A little bit more complex is going to be our real rational exponent problems. We're going to have m divided by n. So all of a sudden that 1 is an m. So ignoring the m for now, everything else is going to stay the same. We're going to have an a on the inside of the root, so my base, a right there. The n is still my root. We just have to figure out what to do with that m. And what's going to happen is we're going to put parentheses around this and raise it to the m power. So bottom of the rational exponent is the root, top is the power. And what we're going to do is we're going to go back and forth with these today. So we're going to start with radical or root form. And we're going to switch to rational exponents. So pay very close attention. A is going to become my base. The root is the denominator of my exponent. And if we have an exponent on the outside, m, that's going to go on top. So this first one, 36. Now it's the most simple one, but a lot of people forget because they look and they see, well, there's no number there. Well, this is a square root, which means it's like there's a 2 out there. So if you want to write that in to see that, you can. So if I want to switch to rational exponent form, I'm going to keep the base of 36. And then since I have a 2 there, that's going to be my denominator. I have no other exponent, so it's going to be 36 to the 1/2 power. Next to it, the third root is 64. My base is going to be 64. Since this is the third root, the denominator is 3. And no other exponent, so my numerator or the top is 1. A few more examples here to fly through. So my base here on the 4th root of 81, I would get 81. Since the 4th root, I'm going to have the 4th power. The numerator or the top is going to be 1. Next to it, the 5th root of 36, going to have a 36. In the exponent, I'm going to have 1/5. So those are the very basic ones. We're going to step it up and get a little bit more difficult. I have the third root of 27, but then this, inside the parentheses, is raised to the 5th power. So let's start on the inside and work our way out. So if I had a third root of 27, I'm going to have a base of 27. The denominator of my exponent is 3. So now we have this 5 that, what we're going to do with it is instead of putting a 1 in the numerator at the top, we're going to put a 5. 27 to the 5/3 power. Here, again, we have the square root of 49. Again, that's like a 2 there. And the third power on the outside. So I'm going to have a base of 49 raised to the 3/2 power. And then one more from rational exponents, from radicals to rational exponents, is we have 4th root of 63 raised to the 6th power. So my base, 63, since the 4th root, we're going to have a 4 on the denominator, and the 6 is going to go on top. So 63 to the 6th 4th power. So we're going to go the opposite way. I'm going to go from rational exponents to radicals. So I have 64 to the 1/3, so I need a 64 inside my radical. Since my denominator is 3, I'm going to put a 3 there for the 3rd root. No other exponent there, so I'm going to leave it as is. Next one, we have a inside our root is our base, which is 36. This is 1/2 power, so what we'd do is we would put a 2 here, but to be a little bit more mathematically precise, we don't write the 2 there. We leave it blank, and that is the square root of 36. Last two examples, I have 81 to the 2/3 power, so the 81, the base, is going to go inside my root. Notice how this one changed a little bit. Instead of having a 1 on top, we have a 2. The 3 is going to go on the root. The only thing we have to worry about is deal with that 2, so we're going to put parentheses, square on the outside. And then my last example, we have 16 to the 5/3 power, so inside my root I'm going to have 16. I just have to figure out what root this is, which is 3, and then on the outside I have my 5. And that was radicals and rational exponents 1.